Welcome students. Today we are going to learn about the chemical properties of metals and non-metals. Reaction with oxygen. You are familiar with the phenomenon of rusting of iron. Recall the reaction by which rust is formed. You had also performed in class 7 an activity of burning a magnesium ribbon in air. You had learned that in both the processes, oxide formation takes place. Now, complete the following reactions of iron and magnesium with oxygen. Let us learn about reaction of iron with oxygen. Here Fe stands for iron and O2 stands for oxygen. In the presence of water H2O, it forms Fe2O3, iron oxide, which is rust. Oxidation occurs when a reactant loses electrons during the reaction, and reduction occurs when a reactant gains electron during the reaction. This often occurs when metals are reacted with acids. Here is the reaction. Iron reacts with oxygen and water to form iron oxide, which is a brown colored rust. Our next topic is testing the nature of rust. Let us perform an activity to find out. Let us check the nature of rust formed as a result of the reaction between iron, oxygen and water. Collect a spoonful of rust and dissolve it in a very little amount of water. In your house, many iron articles may be rusted, so you can collect from there. You will find that the rust remains suspended in water. That means it floats on water. Shake the suspension well so that it mixes properly. Activity 4. Metallic oxides are basic in nature. Test the solution with red and blue litmus paper. This is litmus paper, red color litmus paper. When we are dipping in rust suspension, it forms blue color. So what do you observe? We observe that red litmus turns blue. Is the solution acidic or basic? Metallic oxides are generally basic in nature because basis turns red litmus blue. Here you can see. Next one is reaction of magnesium with oxygen. It is also our fifth activity. Here you can see a gas jar full of oxygen gas. Putting the magnesium ribbon there, so you can see some reaction starts taking place and magnesium ribbon burns with a brilliant white flame. Now let us see the reaction taking place. Reaction of metals with oxygen. Any metal reacts with oxygen to form metal oxide and it is basic in nature. Let us take the example of magnesium. Symbol is Mg, which reacts with oxygen, that is O2. It forms magnesium oxide, MgO. This magnesium oxide is basic in nature and it turns red litmus paper blue. Now recall the activity of burning magnesium ribbon. The ash obtained on burning magnesium ribbon is dissolved in water and tested for its acidic or basic nature. Is the solution acidic or basic? How do you ascertain this? You must have observed that the red litmus turns blue. So, oxides of magnesium is also basic in nature. In general, metallic oxides are basic in nature. Our next reaction is reaction of copper, which is a metal, with oxygen. So, does copper also gets rusted? Have you seen a greenish deposit on the surface of copper vessels? Just try to recall. When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide, which is CuOH twice, and copper carbonate, CO3. The following is the reaction. Two molecules of copper combines with one molecule of water plus carbon dioxide and oxygen to form copper hydroxide and copper carbonate. It turns red litmus blue. Metallic oxides are generally basic in nature. Our next reaction is reaction of non-metals, that is, example is sulfur with oxygen, to be demonstrated by the teacher in the class. What we have to do? We have to take a small amount of powdered sulfur in a deflagrating spoon and heat it. This one is the deflagrating spoon. If deflagrating spoon is not available, you may take a metallic cap of any bottle. Here you can see. And wrap a metallic wire around it and give it the shape as shown in the figure. Reaction of non-metals, that is sulfur with oxygen. As soon as sulfur starts burning, introduce the spoon into a gas jar or glass tumbler. Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus papers. Here are litmus papers. The name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid is formed. The reaction can be given as follows. The reaction is sulfur dioxide SO2 reacts with water H2O to form sulfurous acid H2SO3. The sulfurous acid turns blue litmus paper red. Generally, oxides of nonmetals are acidic in nature. Recall the name of some of the laboratory acids and bases you have read in class 7. Note down their names in table 4.4. In this table, you are supposed to write the names. Identify the metal or non-metal present in them which forms oxides with oxygen. Here is the table. Some of the names are calcium hydroxide, magnesium hydroxide, potassium hydroxide, sodium hydroxide, zinc hydroxide. These are bases. And the metal found in them are in calcium hydroxide, calcium metal, magnesium hydroxide, magnesium metal, potassium hydroxide, potassium metal, sodium hydroxide, sodium metal, and zinc hydroxide, zinc metal is found. Some of the acids are sulfuric acid, hydrochloric acid, nitric acid, carbonic acid, sulfurous acid. In sulfuric acid, the non-metal sulfur is present, hydrochloric acid, chlorine is present, nitric acid, nitrogen is present, carbonic acid, carbon and oxygen is present, and sulfurous acid, sulfur is present. Our next topic is reaction with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. Let us perform an activity of reaction of sodium metal with water. It is very dangerous, to be demonstrated by the teacher only. During demonstration, special care should be taken that the size of the sodium metal piece is roughly the size of a wheat grain. So it should be very small. It should be held with the help of a pair of tongs. What we have to do in this activity? Take a 250 ml beaker or glass tumbler, fill half of it with water. Now carefully cut a small piece of sodium metal the size of wheat grain. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in cotton into the beaker and observe carefully. During the observation, keep away from the beaker. When the reaction stops, touch the beaker. What do you feel? Has the beaker become hot? Test the solution with red and blue litmus papers. Is the solution acidic or basic? Let us find out. See this picture showing the reaction of sodium and sodium with water. Our observations are, we observe that sodium reacts vigorously with water. Some other metals do not do so. For example, iron reacts with water very slowly. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus. It is very reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Dear students, today we have learnt about some of the chemical properties of metals and non-metals, that is reaction with oxygen and reaction with water. Rest of the reaction, that is reaction with acids and bases, we will learn in the next coming sessions. Thank you.